Hey, robot makers, hope we're having a good day so far. So do you want to hack a Billy Mouth, let me get this right, a big mouth Billy Bass robotic fish and control it over the internet? I mean, who wouldn't? So let's dive straight in. My name's Kevin. Come with me as we build robots. I'm getting this terrible today. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to this crazy contraption that I have created. So somebody messaged me on Twitter this week as I was showing some of the progress of this, and they said, Ian said, video title idea, how to control a fish with a cow. Pico. Love it. Oops, I've gone a bit too far there. I think this might swipe off to the right. No, I think we're good. So, yeah, the session goals for today. We're going to hack the original Big Mouth Billy Bass fish with a Raspberry Pi Pico W. This means that we can control this over Wi-Fi. This is the one with the Wi-Fi chip, not like the old Pico chip, which I have here. Which has got the Wi-Fi pack on the back. This is all built in now, so we can do so much with this teeny tiny little chip. So we're going to go over what on earth is a big mouth Billy Bass fish. If you weren't part of the craze in 2000 when this sort of hit the streets and people, everybody, even a Royal Highness was getting in on this, we're going to have a look at what this is all about, how it's wired up, how we're going to hack those electronics and bring it to life. We're going to look at a small 3D printed piece I've made to sort of hold it all together. I'll flip it over so you can see some of the electronics as well. We're going to look through some of the Micropython code that makes all this happen, and then the craziness that is web hosting a Raspberry Pi Pico website. This is a microcontroller, remember, this isn't like a full computer. This is hosting an actual website right now, and it's been online over 24 hours, hasn't gone down yet. So I'm absolutely blown away by just how stable this thing is. And then, of course, we're going to have a bit of a demo. And if you stick around for the Q&A at the end, which is for live stream people only, then we can have a bit of a chat as well. Sandy's saying in the chat, Furby is the next logical step. I've already gone on eBay this afternoon and found some original and Bluetooth Connect versions of the Furby. So that is absolutely going to happen as well, because why not? Cool. Okay, so what on earth is Big Mouth Billy Bass? So, very quick history. So this was an animatronic singing prop which represented a largemouth bass invented by, I think this is Gemi Industries, I think that's how you pronounce it, in and around December 1998. And then it became very popular in the early 2000s. They had a whole range of these. They went on to make slightly different ones. There was like a rock lobster and smaller ones. And then they went for a Bluetooth version, and which was able to connect. I think it had an Alexa inside because somebody had already hacked this to work with an Alexa. And I thought, rather than... I've seen so many projects this week on YouTube about how to flash an LED and access that over a web page, and I thought we can do better than that. We can do so much better than that. Even the web pages looked a little bit rubbish, so we can do so much more with this, and we'll get into the code in a minute. Yes, one of the facts I came across here, it's reported, I wonder if this is by Gemi Industries themselves, that Queen Elizabeth II has a big mouth Billy Bass displayed on her grand piano in Balmoral Castle. So yeah, I'm sure that's true, and there's no kind of marketing stuff going on around that at all. Cool. So how does it work inside? So I flipped the back off this. There's a huge battery compartment with a speaker attached, and there's a whole bunch of wires, and then there's this I'm going to say it's an integrated circuit. These are all through the whole components, so they're all quite low tech actually. I guess this is about 20 years old, but nowadays you would see things in a lot more slimmer form factor, because you've got things like JLB PCB, PCBWay, and all these kind of PCB manufacturers where you can make custom PCBs quite cheaply now. So you wouldn't really use through the whole components, you would use something else as well. This fish is going to be making strange noises throughout the this live stream. So the way that it works, I had to do a bit of research on this myself first. There are 3 motors inside. I can hold 3. They are all around 6 volts as I understand it, 5 to 6 volts, and the power supply, I think it's 4D batteries, so it's quite a hefty battery that's required to drive this. And I've gone through quite a few, and I really don't like the fact that I've gone through these, but gone through quite a few 9-volt batteries which I'm using to currently drive these. There's a button on the front, so you can press a button and it will activate. There is also an infrared sensor, like a motion sensor, that if you break the beam, it will activate and do its thing. Now, I've completely cut away all of those wires that you see there from that original integrated circuit. I think it also had a small audio file that it would play, which is the Don't Worry Be Happy one. And it would play that and it would sing along to it. And then I think they got all the timing just right so the mouth would look like it was singing and so on. There's the speaker in there as well. And the first iteration I'm going to do with this, because there is going to be a second one with some audio as well. I've got one of these Pimoroni Pico audio packs as well to stick on there. And that means we can connect up some audio. I was going to use the Inventor 2040 W, but I thought that would be a bit of a waste on this project, and the way that the motors worked probably wasn't best for this particular device. I'm going to build a specific robot just for this one that'll really use all the features of that Inventor 2040. So that's what I'm intending to do there, Chris. I've already got it in Fusion. So the future iteration is going to play sound, and we'll have clips, excuse me, and we'll probably be able to do a bit of speech as well, because why not? So let's have a look at what we're doing next with this. So the electronic wise, what I've done is I printed out that little yellow piece you can see there. I'll go on to that in a slide in a second. I have two H bridges, which are those squarish looking things that are connected up there. And they're designed for any kind of robotics, really, anything that you need to control two motors per little H bridge with either a 12 volt or a 5 volt supply. And it will actually take up to 12 volts. You can cut the traces inside and have a bit more if you want, but it's got a great big stonking heatsink on there as well to get rid of some of the excess energy if it needs to. So I've got two of those because we've got three motors and I need to be able to control all three. And then there's a little set of pins on the bottom that you can just see just around here. On both of these there's 4 pins, and then there's another 2 pins for enabling those 4 pins, and you've got 2 pairs, one for each of the motors, and they're essentially just enabling or disabling the motor. I think these also do pulse width modulation, so they're based on the is it the L298N driver chip. And yeah, you can either do pulse width modulation and control the speed, or you can just sort of say, here's a 1, here's a full high signal, make the motor go 100%, and that's essentially what I'm doing. And then I'm hooking it up to that little Raspberry Pi W. Really nervous about soldering in the pins there, because if I get it wrong, that's like £6 that I would have to then respend on getting another one, but they are quite easy to get hold of nowadays. There's fresh supplies, so you'll not run out of Pico Ws anytime soon. Okay, and I've got a 9 volt battery to drive, to drive both of those. It's still recovering from my cold, but I think we're nearly there now. So here are the 2 H bridges on the top. We've got the 3 motors, so 2 motors on the left one and 1 motor on the right one. I've then got the 9 volt battery going into the 12 volt on both of the H bridge drivers. The ground goes to both of the H bridge drivers, and the ground also has to go to the Pico. I didn't know this for probably about half an hour, and I thought, why is it not responding to the signals that I'm sending it? Because I can see that the signals are coming through, but it wasn't activating the H bridges, and that's because you do need to have that shared ground between the Pico and the H bridges there. Don't worry about it exploding or burning or anything. That didn't happen to me, so it won't happen to you. So then on the Pico, I'm using pins 0 to 6, which are labelled sort of from that very top left thing there. So 0, 1, then you've got the ground, then 2, 3, 4, 5, and then there's like another ground there. So this is my old Pico graphic that I use. I need to put a little W on there to make it a Pico W. But that's pretty much it. It's very simple to wire this up. I've not included the speaker on this particular build because I'm probably going to use an output from something like this. This has got line output, so I'd have to have some kind of conversion to make it so that it's amplified a little bit for the speaker. You think about how we're going to do that, but I'm pretty sure we can do something with one of these little chips. And yes, the Inventor 2040 actually has a speaker built in. We could have used something like that, but again, I didn't want to use one of these boards. I've got 2 of them, and I want to look after these ones. We're not using the infrared remote, and we haven't got the button either, because we're going to do everything over the internet with Wi-Fi. Okay. So if you like what I do and you want to help with the show, you can drop a like on this particular video, whether you're on Facebook or YouTube. You can leave me a comment, let me know if you think this is crazy or whether I should go ahead with this, develop it more and do the Furby one as well, maybe more than one Furby. Let me know in the comments, and hit the bell as well if you're not already subscribed, and that'll help grow the channel more. We've seen some good growth on the channel at the moment as well. And we do a live stream every single Sunday, and I mean every single Sunday at 7 o'clock, which is British summertime currently, so GMT +1. Whatever the UK local 7 o'clock is, that's the slot I go live. Okay, so the 3D printed part, I thought when I was putting these parts inside the back of the Billy Bass chassis thing, they were sort of moving around, and I thought, what's going to happen here is I'm going to put these wires in, and something's going to pull, and it's going to end up just messing up the arrangement of the wires, maybe short them together or something. So I thought they all had mounting holes, so if I just quickly design, just measure with my digital calipers and throw together some very quick design, Fusion 360 for both of the H bridges and also the Pico there. So you can see the Pico has got a couple of holes there, and these are for the H bridges. And the H bridges weren't from the same company, so they were slightly different in measurements as well. I think one was like 71 and one was 70, something like that, between the distance between the holes. But I basically just give enough tolerance on the holes so that I could put a few bolts through and screw it all together, make it nice and neat. And that really did help. And then what I then did is just hot glued that 3D printed part. I will show you in a second. 3D printed part, just hot glued that to the back of the chassis, the holder of the fish. So yeah, just helps everything sort of stay together, prevents the wires from sort of being stretched, and so on. Sometimes I hot glue wires together as well. Cool. And then I soldered everything together too to keep it all nice and tidy. So Micropython code-wise, there is a link there at the top. You can see if you go to github.com/KevinMcAleer/bigmouth_Wi-Fi, you can access the code there. So we've got Billy, which is Billy.py, which is the Micropython class that I've represented. I've kind of built a robot class just for this, so I can do things like flap the tail or open mouth, close mouth, all that kind of thing. So it looks really easy in the code when we program it later on. And all that's doing is just sending a 1 to the various different pins that we saw on that other diagram. There is an index.html. Now this is a kind of an extension to some of the code I've seen other people do, where inside the Micropython they'll just have like a HTML equals, and then they'll have the 3 speech marks, and they'll just have a small block of HTML within their code. Now we can make it a lot easier on ourselves and make our code a bit more maintainable if we take that out and we have a full HTML file that we can just read in into a variable like HTML, and we'll look at the code in a minute to see exactly how we do that. And this means we can do some cool things with CSS. So a lot of the web pages I've seen don't have any CSS, so they're all in that sort of black and white Times New Roman font, and they look a bit crude and a bit crappy. We can use some CSS and some Bootstrap, which is what I use to build all the websites that if you go to kevsrobots.com or smarsfan.com, they're all built by me using Bootstrap. Bootstrap, some Markdown and Jekyll. I think I did a video on that quite a while ago. So that means that we can have some really small pieces of code, but make it look really nice and have some colour and so on, and add things like buttons. And then we've got Billy Demo 1 or Billy_Demo 1, which is also saved on the Pico as main.py, which means when we plug it in, it runs that automatically, connects to my local area network, and then starts hosting its web page. So we've done some more stuff than that, but I want to actually show you some of the code and show you what's going on. So let me just load up Thonny. The other thing I'll do, I'll switch out the battery, because this thing really eats through batteries. I've got a whole load of these cheap Amazon 9-volt batteries I'm going to have to get recycled. But yes, here's the Billy Bass fish. And if I just spin this round, I can show you exactly what's going on inside. So I'm not using that integrated circuit on the left-hand side at all. I've just got the 2 H bridges, and I can see, yeah, the battery looks very low on there. And if I just disconnect that and get my new battery, plug that in, that'll probably keep us going for a little while. So let's just put that battery in. Yep, that's immediately jumped to life. I can see there's 2 nice red lights there and there, which means that the power's going to it. And then we've got, so the battery's just here. They're sort of connected up there. And we've got the Pico there. I've actually got the ground there rather than in between those 2. There's a couple of grounds around the Pi. They usually have a little square, header mounting soldery point thing, square as opposed to round. And yeah, you can see that there's a yellow and white wire that's going to the main body. Then there is a brown and orange that's going, I think, that way to the tail, I think. And then there's another red and black wire, and that is going to the mouth, I think. I think that's the right way around. And then there's the Pico is just being powered by this this red USB cable, which is it's actually just going to, I'm just going to leave this outside there. There we go. So if I just have that there like so. And if people start pressing buttons on the website, if you go to you can either go to big.mouthpi.co, as in Big Mouth Pico with a full stop, you will see that you can press some buttons. But we're gonna look through the code and then come back to the website in a minute because I want to show you some more stuff on that. I just want to try and make sure that this battery lasts as long as possible. So what I might do is sort of have a bit of a split screen like so we can see what's going on there as well. So if you're pressing buttons on that website, then here is the website itself. So if you go over to mouthpi.co, we got a new subscriber. Thank you for that, Sujit. Yes, what happens when you press the buttons is it fills out a URL, and we search for that URL in the sort of received packages that we get. There you go. Somebody's pressed the button there to I think that will have been move the head in, and if we do like tail out and then tail in, you can see what happens there, or open mouth, close mouth, and then move in. We just move that out the way, move head in or move head out like so. So this is all going via the internet. There you go, somebody else is pressing some buttons, fantastic. Carry on doing that, and we'll have a look at this code. Okay, so what we'll look at first is Billy.Py. So Billy.Py is the class that I created to represent the robot itself. I usually do this when I'm creating robots just to make moving the robot later on or adding behaviors a lot simpler. And we start by just defining what all the pins are. So I just had to spend a little bit of time figuring out which pin corresponded to which pair of wires or GPIO pins connected to the robot motors. And the motors are simply just like you have usually two wires going to the controller robot, and depending on how the wire, the motors are wired, sometimes you have to send like a 1 to both of the things for it to activate. Sometimes it's just a 1. So it's a bit of hit and miss, but essentially they're the pair of pins that go for the head, they're the pair of pins that go for the tail, and they're the pair of pins that go to the mouth. Okay, so then we have a couple of functions, so head out and head in, and they simply just send 1s and 0s to the various different pins. Simple as that. So we've got tail out, tail in, mouth open, mouth close, flap the tail, which is another one. It'll just flap for as many times as you specify. And then I've also got a reset function, which will basically just reset the let me just move this up here, which will basically just reset the robot so that it will get into a position where the mouth is closed, the head is back, and the tail is back as well. That kind of thing. So I've actually not got the Pico wired in at the moment. I'm just going to unplug that and plug in this other wire here, just so I've got not on the battery. Because we're running this completely separated. I wanted to sort of prove that this isn't sort of running by some code in the background. This is all running over Wi-Fi on the device itself. Okay, so that's Billy.Py. We're going to then have a look at the index.html. So if I open this up and I then show you what this looks like, probably the easiest way is for me to go to the developer tools and view the source. So let me just find page source, and we can have a look at what's going on here. So we don't need that, and we just need to move that up a bit there. Right, so if you've not programmed in HTML before, this might look like utter garbage and you might not understand what's going on, but actually it's very, very simple. So we've got the first tag up here which says doc type HTML, and that tells people, or tells web browsers, that this is a valid HTML document. And you've got these things in little brackets. There's always like a bracket facing that way and that way, little triangular brackets, and then in the middle you've got a tag, you've got a keyword. So the first one is HTML, which is like, this is the body of, this is the start of the HTML document, of which there is a head and a body tag. You can also have like a footer as well in there. In the head we've got things like the title. So when we have the title, that's what appears at the top of the page when you load up the page. So if I just bring this down here, that's Billy Bass is what we've typed in the title there. And then we've got a link. So this link is the thing that brings in Bootstrap, which does all the nice style sheets, makes all the colors and makes all the fonts and everything look nice, all the sort of separation on the borders and things like that. That's all part of something called Bootstrap. So if you go to bootstrap.com, you can figure that out yourself. Okay, so next we have somebody's just on a super chat. So could we add a speech chip to read out your tips and super chat messages? We absolutely could, Dean. I think that's something that we've absolutely got to do. You've got to remember that this is a microcontroller, so we are quite limited on what we can do, but we can do things like audio. So that's definitely something I'm going to look into and add to this. Okay, so let me have a look What else we've got on here? So we've got another couple of tags. So this nav thing, this whole block of code here, and I can probably talk you through that later on. That's essentially a navigation link. That's the thing that does this whole piece up the top here. So you've got, that's called a brand, and then you've basically got these list items, and we've got an unordered list. That's what UL means. And then we have list items, and they're of a class navigation item, and that's a bootstrap thing that tells it to apply some nice style, which is basically just the borders and the headers, and put it in a block and so on. So I've got Kev's Robots, which is the Kev's Robot link. We have Kev's YouTube channel, which is the YouTube channel that people are watching this on. And then we have actionsmilersfan.com/join-discord, which is the Discord server link, the sign up link there. Okay, then the next block is the bit that does all the fancy stuff. So we've got a container, which is basically just say, draw a nice area in the middle of the screen. We then have it's a light background, so if you look at the page, it's got kind of like a greyish kind of background to it with nice rounded corners. It then has a title, which is heading style 2, which is Big Mouth Billy Bass, and then it says this website is hosted on a Raspberry Pi Pico in bold, in the robot lab, hot glued inside the Big Mouth Billy Bass. You can remotely control it by clicking the buttons below. And then we've got these buttons. So these are anchors. These are the A tag, and then we have a class of button outline secondary, which just means draw a nice outline button, and then it links to mouthpi.head out, head in, mouth open, mouth closed, tail out, tail in, and then there's a picture of a fish. I've had quite a lot of feedback from people saying like it doesn't update when I press a button. It does this when you press a button. It's actually responding live to your commands. I'm going to have this hanging in the background. I'm thinking like maybe like there or somewhere, or maybe just above there. I'm going to have it there in the background, always on, so people can press that button, because I bought the website. It's there for a year at least now, so why not? Why not? So that's nice and easy. What else we got? And then we've got a status message. Now what I want to do is I want to include a page count, and maybe like, visitor number. How many people have visited this? We can do some Google Analytics. I can add another one of those link things in, like we've got at the top there, to do some Google Analytics to see how many people have hit the Pico web server. But I also just wanted to provide some feedback to people, just showing you just how many commands people have fired in it, and maybe like a history of the past 20 commands, sort of scrolling past. We could do that too. And then we've got a footer at the bottom, which just says me, copyright 2022, why not? And then another link to my YouTube channel. And that's it. So that's the HTML file itself. And what we do inside our demo one, Billy_demo1, is we read that in. So I've also got another file on there which is called secret.py, which is actually on the Pico itself, which has got my Wi-Fi SSID, like the name of the Wi-Fi, and also the password. So it's best practice to save that as a secret file. Have that in your git ignore file, which is the file that tells Git not to upload this to GitHub and share your Wi-Fi passwords with the world. And that means we can bring it in without actually exposing what that is in our source code that we can share. So we also bring in Billy, which we've created earlier in that billy.py. So we bring in that Billy robot class. We bring in sleep and time. We import network, which means we can do all the network Wi-Fi stuff. We bring in the machine pins. I think, I'm not sure why I use that on this code, but I do. And then there's something that's called async.io. I've not seen this before in Python, but I understand what it's for, and we'll talk through that. And we've also got this thing called socket. Now, socket is the sort of mechanism by when you go to the website, the mouthpi.co, you press a button, and that essentially just takes you to another page with a specific URL. So I'll have like /head out, something like that. Socket can read in that request from your web browser, and it can then do something with it. So that's what socket is for. It's for like managing TCP/IP connections and doing stuff with that. So we've then got VLAN. So we create a variable that's called VLAN. We connect to our local area network by using our station interface. We set it to active, to true, so that it's switched on, and then we connect with the SSID and password that we've imported above from our secret.py. And then we have a little thing here which is basically just says, while the WLAN is connected is false, so while it's not connected, just draw loads of dots on the screen. So I should perhaps I'll have a sleep in here so it just doesn't draw thousands of dots, which it currently does. And this comma end equals, when you do a print statement, and you have another print statement, it has like a return, like a new line at the end of it. And if you don't want that, you can just say comma end equals nothing, and it won't print anything at the end of the line. It will just carry on the same line. So that's a nice little tip there. And then we print out, once we've actually connected, we print out the WLAN status. So it'll just say like status 3 or something like that. This is the bit that reads in the HTML file. So we say f equals open, and we open the index.html as read only. We then bring in that code by reading it in. So f.read, and then the HTML variable will contain the entire contents of that HTML file. So we do need to think about the size of that HTML file, because we're bringing all that into the Pico's limited, what is it, 264K of RAM. It's not a massive amount. Excuse me, but for reading in text, it's, you know, we can read in quite a bit there, so that's fine. Now, interestingly, I've linked to, in that HTML file, there's an image. If I just bring this back up a second and I just show you on here, I've got an image that I bring in, which is called Fish1. That isn't stored on the Pico. That's not presented from the Pico. We could do that, but it would make it really slow, because it would have to read it in a couple of bytes at a time and then send that to the browser, because we probably can't read in the entire JPEG at the same, you know, all at once, because we've only got 264K of RAM. So what I essentially do is just say, yeah, host this from a different website. So kesrobots.com is hosted on that little cluster of Raspberry Pis just over there. And I copied up a picture similar to what you're looking at now, but not like a live picture like this one. Just a static picture. Okay, so let's go back to the here. Okay, so we've read in the HTML. The next thing I wanted to do is have a little LED that flashes on and off, just to show that the Pico is active and it's happily ticking away like a heartbeat. So I use onboard equals pin LED, pin out, value equals 0, so it switches it off for now. Then create Billy, which is our fish we can see there, and I set the state is and page view to 0, so we're just initializing them. And then we've got this first thing we might not have seen before, which is async def. So if we've done defs before, we've created definitions, we've defined our functions. Async is a special kind of function, and it's paired with the await function as well. And this is a way of saying, do this thing right away. As soon as this thing is triggered, action this, run this code, forget what else you're doing, run this straight away. But we don't know when it will happen, so that's what the asynchronous nature is. You think synchronize is like you run one line at a time. Asynchronous is that you can run things kind of out of order as soon as some event happens that we want to run this on. So what we're saying is await reader.readline. So we're basically just waiting until we can read in an entire line of text. We don't do anything until that's finished, and then we can then make the request variable equal to whatever we've just read in. So what that async does is basically just says this is going to use some like funky things to do with sockets and asynchronous activities, asynchronous IO, things that are not synchronized or in our order. They're going to happen and we just have to react to them. So it's a bit like a software interrupt in a way. So once we've done that, we can read in that request. We can then find if the URL that's been passed to us contains head out, head in. It's a bit crude, this. This is not really how you build a regular API, but it works for this piece of code. So we're basically just looking to see, does it have any of those? So you can actually go to mouthpi.co/head/out, and it'll make the head go out without having to press a button. So you can basically just hit all these URLs directly and they will action. And all our button is doing is basically just refreshing that page. So somebody's just done it right away there. I can see that battery is probably getting low a bit already. It's getting quite warm there. I think that it's probably not the correct voltage or the correct ampage maybe. So I did have my bench power supply, which is just behind it there, but it was broken. So I wasn't able to run it from there. So I need to get a better battery supply than basically just running through loads and loads of batteries. Okay, so that is the majority of that code. And then we've got a whole bunch of if statements. I've been watching quite a few Python videos recently about how to do better coding, and this is probably quite a bad design pattern. So I probably would refactor this a little bit. But basically I'm just saying if the head out is 6, which is kind of like it is in the request thing that we checked a second ago. So request.find, if we get 6, it basically means it's found that in there. So we can then change the state to Billy's head is out, Billy's head is in. And if you hit one of those URLs, you'll get in the little status thing below the picture, it'll basically just write out that message there. So Billy's mouth is open or something. So then what we then do is we create a response variable, which is that whole block of HTML that we just seen before. And then we have there's two things within that HTML file that have this little percentage symbol. And it means we can pass in 2 other variables and it will replace them, which is quite clever. So if we go back to that HTML file, if you look over here, can I zoom in on that? Maybe if I do that, let's go down to there. So see here where it says status %s, which is like replace this with the first string, replace this with the second string. And then if we go back to our code, that's what essentially will happen. It will say, have this and then replace what is in there, these percentage things, with the first string and then the second string. So the state is whatever we've just said, that message is there. Okay, so then what we do, we then say write this out. So we're going to send this back to the user. That's what you get on your web page when you look at it. This is the bit of code that actually generates that. And then we then say write that out. So this first thing is a header. So this is basically saying, okay, this is a HTML 1.0 compliant page that we're sending back. 200 means everything's good, we're okay. This is the actual code. If you ever go to a website and you can't get the page and it says 404 error, page not found, that's the page code there. There's a whole load of them, like page 500, 503, authentication, all that kind of stuff. So there's a whole load of those. But essentially we're just saying everything's good, and then the content type of this page is text/HTML. And then we've got a series of returns and new lines. So it just does a couple of, there's 2 returns, 2 new lines. So this is like back from the days when we used to have like printers that would have a head, and it would have the paper would roll on a little carriage, and you would have to tell the printer how to do things. You could say print out this text, and then you would have to say return, which would make it go right back to the beginning of the thing, but it'd still be on the same line. And then you'd have to say carriage return, and that would turn the carriage 1 line so that the paper would move up 1 line. And that we're still doing that in HTML, which is just crazy. And then we write that response out, which is the thing we've just built. And then we then say await writer.drain. So drain this thing. So it basically is just sending it as a buffer out to your browser. And once it's finished draining, it's sent all that to your browser. It then has to await that connection to be closed. Your browser only connects momentarily to the Pico to get the page, and then it disconnects its connection. So TCP/IP isn't like a phone call where you both sort of are on the phone at the same time and you've got an active connection. It's more like sending postcards, and when you've received enough of these, you can then build out what the message is. That's kind of how TCP/IP works. UDP, if we're being technical there. So once we've done that, we can then say print client disconnected. And then we've got the main piece of code here. So it says setting up the web server. And again, this is another asynchronous one. And then we say asynchronous create task. This is a thing that makes it magically work in the background whenever a response is sent through, a request is sent through. We say async IO, start server, server client, and then we pass in the IP address. So 0.0.0.0 means use your local IP address, whatever that is, because that might change if we've got a DHCP connection on our network. And then we have port 80, which is what all web browsers use by default when you're sending and receiving messages, sending web pages between each other. And then we've got another piece of code which really doesn't do very much. It just creates a little heartbeat. So we switch the onboard LED to on. We do our little print heartbeat. We wait for, I think that's 1/4 of a second, and then it's an asynchronous wait, so we're not actually holding up any code. This is a clever way of saying if there's anything that needs to be done asynchronously, do that now. Meanwhile, we're going to wait for 1/4 of a second, and then we're going to switch the LED off, and then we're going to wait for 5 seconds just so we haven't got loads of heartbeat messages occurring. And then after this, I've got a Billy reset. We've got a sleep for a second, move the head out, move the tail out, sleep for 1/2 a second, and then and this was a little loop I was trying things out. So for underscore in range 1 to whatever number I wanted to do this, how many times I could make him open his mouth and close it very rapidly, so he'd sort of chatter like that. Then, move the tail in, move the head in, and then flap the tail a number of times. Then finally, this is the bit where it runs the asynchronous code. So we then say try asyncio.run main, and that's the asynchronous main that we've just defined up here. So it's going to run that, and then finally it's going to then say new event loop. So it's going to run that, and because it's all synchronous and it happens right away, it will then say asynchronous new event loop. So check out Async.io if you've not come across this before. You need it when you're dealing with network traffic and things that have to happen sort of immediately. Otherwise, if we had our code sort of going through, waiting for 5 seconds, and somebody sends through a request for your web page, it would basically just say page not found, because it would time out. So that's what this asynchronous thing does. It allows things to happen when they need to happen. So that's the code. So let's go back to our keynote. And let's talk about web hosting for a second, because this got really complicated quite quickly. So I've got my Raspberry Pi Pico running on my local area network. So it's connecting to the Wi-Fi, which is just underneath my desk there. I should really have it high up, but I've got it actually under my desk there. And it connects to my local area network. My home router detects that this needs an IP address via DHCP requests. It sends it a DHCP address, and it tends to stick that to the same MAC address. So inside that little chip there, there's a little address that says I'm always the same address, I'm always the same device, so give me an IP address. And the DHCP server can either give it a random IP address from the little pool that it has, or it can give you the same one each time. So I tend to make them sticky, so it always gets the same one. And that means that when the DHCP addresses, they expire after a certain amount of time. It could be a day, it could be a couple of hours, whatever. It then doesn't just get a random one, because I need to be able to say exactly which IP address this is, and then do some clever things with routing. So what I then do, excuse me, I tried to get away with not coughing. I went to my favourite web host, which is GoDaddy.com, not sponsored at all, and I bought a Big Mouth Pico, which is big.mouthpi.co. .co were quite cheap. I think they were like 99p for the year or something like that. So it was quite a cheap project to be able to sort of set this up. What I then needed to do, because I could just register that and direct all the traffic that goes to Big Mouth Pico, I could direct all to my router, and then when it comes into my router needs to know what to do with all this traffic. So it directs it to my load balancer. My load balancer is that little group of Raspberry Pis that are just next to that little, you can just see some lights flickering there. There's 4 Raspberry Pis in there, and one of them has the job of being the load balancer. And that Raspberry Pi cluster, excuse me, will host all of my websites, so kevsrobots.com, clusteredpi.com, and now Big Mouth Pico. So what it then does is it says, right, this is a website request for Kev's Mac, so I'm going to send it to the first Raspberry Pi, and then if somebody requests the same site, it'll then go to the second Raspberry Pi, and it'll go round robin, they call that, until all that traffic has been distributed. So that's called a load balancer. Now you can use your load balancer to direct traffic to anything that's on your local area network. You can still hear, let's just grab another camera on here so that we can. If I just move this down here and then change it to the overhead, which is that one, there we go. We can have that just in the corner, just so you can see what's going on. There we go. You can even make that a little bit rounded corners as well. There we go. Yes, so what happens when you go to Big Mouth Pico, that traffic goes to my router. My router then says, I'm sending all that traffic to the load balancer, and then the load balancer says, is this a request for Clustered Pi? Is it a request for Kez Robots? Or is it a request for Big Mouth Pico? And there's a little Nginx thing. That's what's actually running in a Docker instance, if you want to know how that works. And it basically just redirects that traffic then to the Pico. So on that little IP address there, 192.168.1.65 is what my local IP address is for the Pico that's in the fish there. And then that code that we've just looked at, it then responds to your requests, and it sends it all the way back up to the browser, the person on the internet. I'm going I just got my mute button there. Okay, so I've got a question there from NeverSync Makes. He says, do you need your Pico's local IP, or can you use the host name picow.local? So you can if your router is doing your DNS resolution. For some reason, the BT Smart Home Hub 2 thing that I have is rubbish at doing local DNS. I could probably sort this out by running all this on a Raspberry Pi Pico, a Raspberry Pi 4 as part of that cluster. I basically have that do all the name resolution and everything, but it's one of the things I've just never got round to. So I don't find any success with the picow.local, but that should work in theory. It should get resolved properly. Okay, so let me just go back to the keynote there. Okay, let's have a look and have a bit of a demo, shall we? So let me go over to, in fact, which way is the best way to do that? I can close that one out now. So let me bring up a web page, which has got Billy Bass on it there. So you can do this as well if you want and play about, because this is what's so cool about it. Now what I could do is I could disconnect that momentarily, plug it into Thonny, and we can see all the requests coming through, or we can just press buttons on here and see what happens. But I think that battery is getting quite warm now and is probably not at its best. But let's try moving the head out. So I'm going to click that. Let's see what's going on there. I might just swap the battery over and see if that's going to work any better, because I think, yeah, there we go. So move the head in, open the mouth, close the mouth. Oh yeah, the battery's definitely going there. Look at that, mouth open, mouth closed, it's barely moving. Move the tail out, move the tail in. There we go, tail in, tail out, that's working all right. I think it takes quite a lot of battery power to pull the head out, like that, and then back in, like that, out, and then in. So Mohammed is asking, do I have fixed IP hosting for my websites? So yes, so I have a small business I run in the UK, and because of that I have a dedicated fixed IP address, but I don't actually want to expose that to the world. I did used to do this and host all my websites on my own IP address, and somebody said you really should be using Cloudflare, and that means you can protect against denial of service attacks, because if there was somebody malicious out there, I think Jeff Geerling did a video about this because he had exactly this happen with one of his websites. So he runs is it Dramble Pi or Pi Dramble? Is it PyDramble something? Let me just find that. There we go. So if I go to his Raspberry Pi cluster, so he's got a very similar kind of Raspberry Pi cluster going on in his house, and that's what his looks like. Similar kind of setup, and I've got basically the same thing going on, but on Clustered Pi. So if I go to clusteredpi.com. That's my version of it. That's what it looks like there. You can just see that same setup just there with a little screen next to it. That's what this one is here. And we also have the other clustered Pis, which are basically just on this desk over there, which is a whole group of Raspberry Pi 02s, I think they are. So this is all hosted on that particular group of Raspberry Pis, load balance. So each of them, there's 4 of them, all running a Docker instance, running Nginx, hosting static web pages essentially. So you can actually scroll down on this one and see which server is actually serving you. So you can see there that says node 1. So if I just let me just get this all in the same shot so you can see what's going on. If I bring that down, let me just get it all on the same page. There we go. So see there it says node 1. If I hit refresh on there, it will then pick another node. So we've got node 3, then we've got node 2, node 3, node 4. So all 4 of the nodes are firing at the moment, hosting this web page. So that tells you which of the 4 Raspberry Pis there is hosting the page for you. And it's seamless. You don't even know that that's happening. It's really nice, and that's load balancing. So let's go back to Billy Bass. Let's see what's going on there. So what happens, like I said on that diagram, I'm hosting this on the Pico. The Pico is then receiving messages which are getting load balanced from that little Raspberry Pi cluster, because I get all my port 80 traffic directed to that one IP address, and that load balancer then basically just spreads that out across the 4 Picos to serve up pages or anything else that I want to share with the world. I then had to go to GoDaddy, buy a domain name, change the name servers, set up Cloudflare, which takes a couple of hours maybe to set up properly. They're really helpful in how you get it to do, and it's completely free as well. Cloudflare have this free package for doing that, so you can basically just have a MouthPi or whatever website you want directed and I can just leave this going now for the year in the background. I just need something to power it a bit better because those batteries are nearly on the way out, I think. So yeah, if you want to watch the YouTube video about this video you're watching now, it's here. YouTube video about this video you're watching now. How cool is that? It's here. There we go. That's the link to it. That was quite cool. And there's a static picture of the Billy Bass, and you can see there the last thing that we did, that's the status message there. So what I could do, because there's actually only 8 states that this robot can be in. It can either be with its mouth closed, its head back, and its tail back. Oops. So that's the first state. It can have the tail up but the head back and the mouth closed. It can have the tail back, the head up, and so on. There's only 8 possible states because it's like 2 to the power 3. There's 2 states that everything can be in, and there's 3 motors. 2 to the power 3 to the power 2, 2 to the power 3, 3 to the power 2 is 8. So it's like you just need 3 bits to be able to control this essentially. And the 4th bit would be like, you know, if you've got 1, 2, 4, 8, we've actually got 8 different states that this can be in with 3 pixels. 3 pixels, 3 bits. So that's how it actually works. Yes, Neversink says 2 to the power 3. There we go. So yes, that's how that actually works. And this is pretty cool, isn't it? So just a very simple web page. And what's really blown me away is that this web page has been up for over 24 hours now. That's one of the reasons I want to upload the code and improve it a little bit, because I want to see just how long this has been up for. Because this is a microcontroller. This is like an Arduino on steroids. This is a Raspberry Pi Pico, a little 32-bit microcontroller with a whiff of memory. 264K of memory is not a great deal of memory. It's running a full-blown web server, and it's able to make that web server, that web page look quite nice. So this is all the Bootstrap. These are all the nice things that Bootstrap comes in, like the rounded corners. This is like a Jumbotron from back in the day. These are nice buttons. We've then got an image which has got nice rounded corners, and the image is perfectly scaled because it's inside a container. All that kind of stuff is Bootstrap. And then things like this is the code tag, so it puts it in a nice kind of fixed width font. And then at the bottom we've got the footer as well, with everything linkable. Excuse me a second. So yeah, I thought this was a really cool project. So sort of next steps with this, if I just go back to my slides for a second. Oh yeah, if you want to join me on Discord, you can hop over to action.svamarsfan.com/join-discord, or you can go to the Big Mouth Pico and click on the Discord link as well, or you can go to kevsrobots.com and click on the link there as well. They'll basically just take you to a sign up page, and it's just so you can join the mailing list as well, but you also get access to Discord, which is the really, really cool thing. And that's all my slides for today. So is there anything else you want to see on there? Do you want to have a bit more interactivity? If you've not already messed with the fish, then now's your opportunity, because I'm going to be disconnecting this camera and the live stream very shortly, and you won't be able to see what's happening. But I could take those 8 pictures, so at least when you press the button you can see what state it actually is in, but you can see that it actually does do stuff and it is live. So all those people that have been pressing it, thank you for joining in with that. Cool. So this is the point in the video where I say thank you very much for watching along with me. If you want to help support out the channel, you can do. There's a couple of different things you can do. You can go over to buymeacoffee.com/Kevin McAleer. You can help pay for the website hosting, the royalty-free music that I have to pay for, the graphics software I use to create all the graphics and stuff for the slides, the streaming software I use to actually go live in front of you now. There's like 2 lots of that. There's a Restream and there's also Ecamm. They're both subscription based, and also all the equipment I use. So there's like lots of cameras. There's an expensive camera, overhead camera here. I can actually show you that. If I go to this camera view here, this is my little hand camera. I can move things around so you can just see, there we go. We have the overhead camera there, and then over there we've got the main camera, which is just there, and this is my messy desk. And that's the view I can see when I'm sort of looking at you guys. So that's the little hand camera there. So if I go back over to there for a second, so that's buymeacoffee.com/Kevin McAleer. I do go live every single Sunday, 7 o'clock GMT, GMT +1, depending what time of year it is. There are the different time zones. If you know where you are, you can look at that, pause that. And what else have we got on there? Yes, if you've not been to smarsfan.com, this is where I started my YouTube journey, building videos for Smarsfan. Smars are these little robots that are based on the Arduino Uno. There's all kinds of tutorials on there. There's also a Python tutorial as well if you want to check that out too. So there's a whole load of different ways you can help out the channel if you want to. You can also do super chats if you're on the live, or you can press that thanks button, super thanks button on the YouTube video as well. Cool. So this is the point of the video where I say thank you very much for watching, and I shall see you next time. And if you're watching live, we get to do a bit of a Q&A now as well.